Okay guys, let's do a little factoring of these polynomials. And sorry I'm not in class today, but I will be there tomorrow. I just have to go to this training, can't get out of it. Here we go. So let's first remind ourselves, whenever we see standard form like this, we have a squared, we have in this case a n term in the middle and a number at the end. If this number was missing right here, guys, then we would just factor with GCF, right? But anyways, in our case, what we're going to do instead is we're going to make our x. We know we're going to use an x method, right? We know this 20 goes on top. The minus 9 here goes in the middle. And then it's just a matter of figuring out the right combination. So for example, if I try 2 times 10 for 20, can I get this 9 here at the bottom? No. So I have to think of another way to get 20. And it so happens to be 4 times 5 is 20. Now, to get a negative 9, watch your negatives here, guys. I want to make sure these are both negative. So that's why I know my final factored form is n minus 4, n minus 5. Or n minus 5, n minus 4. Remember, guys, commutative property always works for multiplying. So I can literally switch these factors around. And remember, these are called factors. Hence the name, we are factoring. All right, let's try one more basic one. So when I do my x here, I want a 32 on the top. I want a minus 12 in the bottom. 4 times 8 is 32. And I can get a minus 12 if I make them both negative, right? So n minus 4, n minus 8, or I could say n minus 8, n minus 4. Now let's do one that we started learning about yesterday that's a little bit more challenging. So notice what's different about this one, guys, is I have this 3 here. Right? And if I try to divide each of these by 3, this does not divide by 3, right? 37 does not divide by 3. So therefore, I'm stuck with the 3. So when I set up my x here, we have to remember to always take the first, that 3, we have to include it in our factoring, see? So instead of 90, I have to do 3 times 90, and that gives me 270. Use your calculator if you need to for that, guys. And notice the middle is still negative 37. So there's our setup. Now, can 3 and 90 make 37 or negative 37? No. So this is where I remind you guys how important it is. You must use a calculator. You must use a calculator. Okay? So, and here's what I would do. Since 3 didn't work, how about we tried 270 divided by 4? See how I get a decimal. I try to divide it by 5. Now I get 54, but can 54 and 5, remember we're trying to make this 37 here. It doesn't work, right? So I keep going on. I try to divide by 6. It works, it's 45, but does 45 and 6 make 37? No. So see how I just keep dividing, guys, until I find the right combination. I divide by 7, I get a decimal. I divide by 8, I get another decimal. I divide by 9, I get 30. But can 30 and 9 make this 37? No, it can make 39, but not 37. So I do one more. Once I divide 270 by 10, I get 27. And 27 and 10 can make 37. So I know I'm going to do 10 times 27. Now to get the negative 37, I got to make them both negative. So I have n minus 10 with an n minus 27. Now I'm not done, guys, because I need this 3 here. I either need to put it there or there. so I can get my 3n squared back, you see? Well, can I divide 10 by 3? No. Can I divide 27 by 3? Yes. So since I can divide this by 3, I now know I can times the other factor by 3. And my final result is 3n minus 10 times n minus 9. Again, don't forget to divide the 27 by 3. And there is our factored form. So hopefully, guys, you'll use the calculator today, even though I'm not there. And you just need to struggle with this a little bit. It's okay if you make mistakes. Struggling means you're learning, okay? Just don't give up. You'll notice the worksheet has the answer key along the side as well, so you don't have to worry about the sub having to help you, okay? But besides that, guys, I need you to try your best. Make sure you get this factoring down very well. It's one of the most important things that I have to teach you this year. See you in class tomorrow.